Today students will learn how to solve quadratic equations by graphing and then also how to solve them by the algebraic methods, and there's more than one. So let's just talk about what does it look like when you look at a quadratic equation, and then how does the graph lead to the number of real solutions of the quadratic equation. So if you look at the quadratic function whose parabola is right here, this red one, y equals to 3x squared. So what we're doing when we say solve the quadratic is we're looking to see where does this parabola hit the x-axis. So we're looking for x-intercepts, and it's hitting right at 0. So if we were to solve this by hand, we would say x equals 0 is our solution. And what if I put in minus 6? So now I'm looking over here at this point right there, which is negative 1.414. X equals that would be a solution, along with this one over here, positive 1.414. If I look at this equation, I've got two solutions again, negative 1 exactly, and then 0.3 repeating. So what we're doing when we're looking at quadratic equations is if they're already graphed for us, it's a lot easier. We're just looking for the x-intercepts. What could potentially make this somewhat difficult is if we had to do all that graphing first and then solve it ourselves. Okay, so using our technology, what does it mean? So how does the graph of a quadratic equation lead to the number of real solutions? We can see the real solutions by looking for the x-intercepts. Now the words solutions, zeros, roots, they all mean the same thing. So if I look at this quadratic equation hitting the x-axis, I'm like, oh, there's a solution and there's a solution. So a solution is where the graph hits the x-axis. The reason why they call that zeros is because when we look at the function, we're looking for when the entire function is equal to 0. In other words, 0 is your y variable, and we're looking for the x. And then roots is just another name for solutions or zeros. Now I mentioned this just a second ago, but there's two ways you can find the solutions, graphically or algebraically. So graphically is everything we just talked about. Now algebraic, there's a couple ways. So if the graph is already drawn for you, I would say by all means do it graphically. Just find the x-intercepts. So here's an x-intercept here, and here's one here. So we would say our solutions are x equals negative 2 and x equals 3. And we're like, whoa, we're done. Over here, the only time it hits is right here. So you can see that sometimes a parabola has two answers, two solutions. Sometimes it has one, and sometimes it has no real solution. And that's when your graph will never hit the x-axis. Now, how do we use our graphing calculator to try and solve? The first thing is we would want to go into the y equals function of our graphing calculator, and then we want to type in the problem without the equals 0. Now notice on this one it's all wacky. You've got the x squareds here, you got some other stuff here, so you need all this stuff on the same side as your x squared. So we would have to subtract 6x and add 20. Remember, we have to do the opposite to get it to the other side. So our problem is going to be half x squared minus 6x plus 20 equals 0. And then we can type in y is equal to half x squared minus 6x plus 20. So let's take a few minutes and let's graph that on our graphing calculator. Alright, so if we look at this function, y equals x squared plus 3x minus 10, we can see that it hits the x-axis at negative 5 and 2. Now, how do we know for sure if those are correct? We're going to check it. We're going to plug negative 5 in wherever there's an x. So negative 5 squared plus 3 times negative 5 minus 10. Does that give me 0? Would that be 25 minus 15 minus 10? Yep, that works. Now let's try 2. 2 squared plus 3 times 2 minus 10. Does that give me 0? Yep. So graphically, I just graphed it with my graphing calculator. I go, boom, I got my answers, and I'm good. Remember, it's going to be a little bit more difficult when you have to graph it by hand like you did last chapter. All right, so let's look at this next equation here. Half x squared minus 6x plus 20. So if you take a look at this graph, notice where it hits the x-axis, it doesn't, and therefore it means that we won't have any solutions. So then over here, I'm going to write no real solutions.